Okay, continue with 10.5. If we're going to convert this complex number into a polar form, the first thing that we need to do is find r, which is the square root of x squared plus y squared. Our x is negative 2 square root of 3, and our y is 2. So r is negative 2 square root of 3, that whole thing squared, plus 2 squared. So this is the same thing as negative 2 squared times the square root of 3 squared plus 2 squared, which this would be 4 times 3 plus 4, which this would be 12 plus 4, which that would be the square root of 16, which r is just going to be 4. Next thing to do is to find your argument or your theta. So x is equal to r cosine theta. Our x is negative 2 square root of 3. The r that we just found is 4 cosine theta. Divide both sides by 4. So cosine theta would be negative 2 square root of 3 all over 4. I can take a 2 out here and here, which would leave me with negative square root of 3 over 2. And I'm going to move cosine over, so theta is equal to the inverse cosine of negative square root of 3 over 2, which gives me 150. Now before I say, okay, my answer is 150, let's make sure that we're in the right quadrant. So our x is negative and our y is positive. So x is negative, y is positive. So we should be in the second quadrant. Well, 150 is in the second quadrant. Because remember, the inverse of cosine, that's going to give you angles in quadrant 1 and quadrant 2. Since we are already in quadrant 2, we don't have to change anything. We can go ahead and take the 150. Alright, so our polar form of our complex number would be 4 cosine of 150 plus I sine of that same number, 150. And that would be your final answer right there. Okay, if we go backwards, now they've given us a polar form and they want us to go back to the complex number. Well, here they say that r is the square root of 2, and our argument or theta is pi over 4. To get back to x and y, or to get this form right here, we said x is equal to r cosine of theta. So x is equal to the square root of 2 times the cosine of pi over 4, which is just 45. So x is equal to the square root of 2 times, 45. So 45 degrees, 45 degrees. This is a special triangle. 1, 1, and square root of 2. So this would be 1 over the square root of 2. Notice that I got a square root of 2 in the top and the bottom. They will cancel out. So that would just be 1. We'll do the same thing for y. So for r sine of theta, r is square root of 2, sine of pi over 4, which is 45. The square root of 2 times, well, sine is going to be y over r, so 1 over the square root of 2, and it comes out to the same thing, 1. Okay? So therefore, it should be 1 plus 1i, which is the same thing as 1 plus I. And that's your final answer. All right, now if we take a look at multiplying complex numbers that are already in polar form. So if we have this complex number right here, and then another one, and we're going to multiply the two. So z sub 1 times z sub 2. Then it's really easy. All we're going to do is we're going to multiply the modulus together, and then we're going to add the angles together. That's what they're doing right here. Okay. So there you're multiplying your modulus, and here you are adding those two angles together, and that's really it. So if we're going to multiply these two complex numbers that are in polar form, z sub 1 times z sub 2, then all I'm going to do is take the modulus for z sub 1, multiply it times the modulus of z sub 2, okay, and then I'm going to take those two angles, 80 and 45, and add them together. And do the same thing with sine. So 80 plus 145. Okay, so 4 times 2, that would be 8. Cosine of 80 plus 145, that is 225, plus I sine of 225, that same number. Okay, so if we take this down all the way back to a complex number, well, then I need to figure out what is cosine and sine of 225. So that's going to be in quadrant 3. And so all of this is in quadrant 3. To get this little angle right here, what I would do is 225 minus 180 to give me a reference angle of 45. Okay, so this is 45, 90, 45. We're back to the special triangle. So that's 1. That's negative 1. That's square root of 2. Okay, so this is equal to 8 times. Okay, so the cosine of 225, that would be negative square root of 2 over 2. And plus I times sine of 225, that is negative square root of 2 over 2. Okay, so now what we're going to do is multiply the 8 times this term right here and this term. So really what you're doing is you're taking half of 8. So this would be negative 4 square root of 2. You take this negative right here, put it in front, minus I, and then we'll have a 4. So I'm actually going to put the 4 in front of that I. So 4I square root of 2. And that's the product of these two complex numbers in trig form. So this would be your final answer right here. Okay, now this question is one of the more difficult questions. We have two complex numbers that are in polar form that we're going to multiply together. So right now, these are not in polar form, they're in the complex form. So the first thing that we need to do is to change each one of them to the polar form. So if we look at this one first. Okay, the first thing I need to do is to find r. So r is equal to the square root of x squared plus y squared, which our x is negative 2 and our y is 2 square root of 3. So negative 2 squared plus 2 square root of 3, that whole thing squared, which that's the same thing as 4 plus, okay, the 2 gets squared, so 4, and also the square root of 3 gets squared, so that would just be 3. So this would be 4 plus 12, which would be square root of 16, which would be 4. Okay, so then we would have to find the argument for that, which we start with x is equal to r cosine theta. So our x is negative 2, our r is 4 cosine theta. Move that 4 over. So we've got cosine theta is equal to negative, there's a 2 here, and I can take out a 2 here, so this is really negative 1/2. So theta is equal to the inverse cosine of negative 1/2. Alright, so when we plug this in, we get a theta of 120. Make sure that's the theta that you need. Our x is negative and our y is positive. X is negative, y is positive. We are in the second quadrant, which the inverse of cosine will give you answers in quadrant 1 and quadrant 2. So this 120, yes, that is in quadrant 2, so we don't have to change anything for that one, so that's fine. Okay? So then we go back and we do the same thing for the second complex number. So we'll have r is equal to the square root of x squared plus y squared. Now I'm not looking at this one anymore. I'm looking at this one. So our x value is the square root of 3. We're going to square that plus 1 squared. So this will be 3 plus 1, or the square root of 4, which will be 2. And then we'll find x is equal to r cosine theta. Our x here is the square root of 3. Our r is 2 cosine theta. Divide by 2 by both sides. So cosine theta is square root of 3 over 2. So theta will be the inverse of cosine of square root of 3 over 2. The theta that it gives us would be 30 degrees. Okay, same thing. So my x is positive and my y is positive. So I should be in quadrant 1, which 30 is in quadrant 1, so I don't have to do anything to it. That's already in standard position. Okay. So now, the z sub 1 over here is 4 cosine of 120 plus I sine of 120. And over here, z sub 2, this would be 2 cosine of 30 plus I sine of 30. Okay, now I can multiply these two polar forms together. Alright, so to multiply these two together, so z sub 1 z sub 1 times z sub 2. What we're going to do is we're going to multiply moduli together. So that's going to be 4 times 2. And then times, this will be cosine. We're going to add the 120 plus the 30. So 120 plus 30 plus I sine of 120 plus 30. So that gives us 8. And then cosine of 150 plus I sine of 150. Okay. Then we need to figure out what is cosine and sine of 150. So this little angle right here, which would be 180 minus 150, which would be 30. So this is 30. That's 90. This is 60. This would be square root of 3. That'd be negative. This would be 1. This would be 2. Okay, so 8 times cosine of 150. That would be negative square root of 3 over 2 plus I. Sine of 150 would be 1/2. So we'll take 8 and we'll distribute to this term and to this term. Or it's really just saying half of 8 because of this 2 on the bottom. So this would be negative 4 square root of 3 plus 4i. This right here would be your final answer. Now again, like I said, this was one of the harder versions of these types of problems. So if you're able to do this on your own, then you are golden for the test.